Okay, today we're going to start by talking about a word that most of us have been saying for a very long time. We've heard a lot, but we want to make sure we're actually talking about the same thing. And that word is solve, right? That word is solve. So a lot of us think that solving means getting the answer or coming up with a response to a question, but the word solve in math has a very basic level of a definition, okay? And that definition, and I want you to write this down into your notes, that definition is to get the variable by itself. And I'll say it again. Solving means to get the variable by itself, okay? So when I'm talking about by itself, right, basically what I mean is I'm going to create a random equation here. If I just wrote an equation that said like y plus 2 equals 10, okay, so when I'm talking about by itself, what I mean is that there are two sides to an equation, right? If I just drew a line right here, okay, down across the equal sign, you can see I've split the left side and the right side of the equation, right? The left side, right, and the right side, right? So when I say I want the variable by itself, when we say we want to solve, we just want the variable on one side or the other all by itself. Okay, so in this particular problem, this is not solved, right? This is not solved because the y has a 2 next to it, right? This 2 is on that left side, just like the variable is. Okay, so this is like an x, like no, right? It's not solved. But if I wrote an equation that looked like this, right? If I wrote an equation that said y equals 12, now if we look, right? Now if we look, there's only one thing on the left side. And that thing, right? That thing is the variable. So this variable is by itself right now. There's nothing else over here. And it could also be the same if we had just kind of written it backwards, right? If I had written 7 equals y, this is also by its side, right? There's nothing else on the right side with our variables, okay? So that's what I mean by getting the variable by itself. So the first one, the answer is no, because there's a 2 over here, but these two are good examples of the variable being by itself, right? Being by itself on one side, the equal sign. So that's what solve means, right? Solve means to get the variable by itself, right? And the real question, the real crux of this is how do we do that, okay? How do we get something by itself? So I have two ways, right? I have two ways to solve, and this is basically any equation, all right? This is basically any equation. We're going to start with really easy ones today, right? These are known as one-step equations, meaning we'll use one step to solve, right? So the first step is always to do the opposite, okay? Do the opposite, right? So just as a quick heads up, what's the opposite of adding? Well, subtracting, right? What's the opposite of dividing? Multiplying. And this is a trickier one. What's the opposite of using the square root? Well, that answer would be to square, right? Squaring is the opposite of squaring. So we're looking for opposites, right? We're looking for opposites. And the reason we're looking for opposites is because opposites cancel, right? Opposites cancel with each other. So we're going to do the opposite. And then step 2, right? The second rule here is we do it, and it is meaning the opposite. Do it to both sides, right? So we do it to both sides. And when I'm talking about both sides, I'm talking about both sides of the equation, right? If we have the left side and the right side. So if I add 2 on the left, I must add 2 on the right. If I subtract 15 on the right, I need to subtract 15 on the left. So these 2 rules are going to let us solve basically everything, even really, really hard problems. We just need to know to do the opposite. We need to do it to both sides, right? So let's go ahead and apply that. Let's take that into these 4 problems. I have problems 1, 2, 4, and this is a problem G. Okay, so if you're following along in your ebook, let me check here. If you're following along in your ebook, I believe this starts on page 438. Okay, and this is example 1 on 438. All right, so what we need to do is we need to look up here and let's decide if this equation is solved. Yeah, right? If it's solved. So the question is the variable by itself? Well, the answer is no, right? If I drew a line through the equal sign, there's obviously this 6, right? This 6 is over here. Okay, so the x is not by itself. The 4 is by itself, right? But solving means we need to get the variable by itself. So right now we have that pesky +6, right? And the +6 is just in the way. We need it to be gone. We need it to get out of this problem. So what I'm going to do is I'm going to follow my steps. I'm going to do the opposite, right? I'm going to do it to both sides. So right now I have a +6. So what is the opposite of +6? Well, the opposite of +6 is -6, right? -6. All right, so that's the opposite. So we've just done step 1, right? We did step 1. We subtracted, we did the opposite. Step 2 says do it to both sides, right? Both sides of the equal sign. So if I subtract 6, if I -6 over on the left-hand side, I must do that on the right-hand side. I must say 4 minus 6. Okay, so from this stage, right? From this stage, we're almost done, right? That's why it's called one step. Basically, we're doing one thing. So what happens to 6 minus 6? What do opposites actually do? Well, they cancel, right? We could just erase these things because 6 minus 6 is 0, right? So what we need to do is we need to say x, right? X equals, what is 4 minus 6, right? So I'm going to use a number line, but you can use this on your calculator, right? You can use your calculator to take 4 minus 6. So here's 4, 3, 2, 1. Minus means move to the left. So left 1, 2, 3, 4, 5, and 6. It looks like x is equal to -2. Okay, so 4 minus 6 gives us -2. And now you can see, remember, the definition of solving means the variable is by itself, right? This x is by itself now. There's nothing over here with it, right? Let's go and try problem 2, okay? So first off, we're going to start by doing the opposite, right? So I see here's the b, right? Here's b, and here's a +8, right? We have a +8 next to it. So what's the opposite of +8? Well, the opposite is -8, right? The opposite would be -8, right? So I have b minus 8. And step 2, right? That was doing the opposite. Step 2 says do it to both sides, right? Do it to both sides. So if I'm going to subtract 8 over here on the right, I have to subtract 8 over here on the left. Right? Now, the reason we do the opposites, right? Because look at our 8s. I have an 8 minus 8, and those two cancel, right? Those two cancel with each other. And so I'm left with -5 equals b, right? But I got a -8 over here, so I need to say -5 minus 8. If you can't do this in your head, you can use a number line or a calculator, but -5 minus 8 is a -13. Okay, so b kind of looks like a 13 itself. B is equal to -13. Okay, so let's try problem 4, right? Let's try problem 4, which is in the top right corner. Reminder that we are doing the opposite, right? We're going to do the opposite first. So I see a -2 here, right? -2, we were trying to get stuff away from the x, right? Because we want the x, solving means to get the x by itself. So I'm going to try to move this -2 over here. So what's the opposite of -2? +2, right? It should be +2. So if I add 2 on the left side of the equal sign, right? That's doing the opposite. Step 2 tells me to do it to both sides. So if I add 2 on the left, I must add 2 on the right. This one might be our easiest one. So what happens to these two opposites? What happens to -2 and +2? They cancel, right? So I'm just going to erase them, okay? You could cross them out if you wanted to, but I'm just going to erase them. And so now it becomes, our one step is, what is 1 plus 2? Well, it's 3, right? So x equals 3. Okay, so last question here, last question. And it says, looks like my green ink is a little faded there, right? Looks like it's a little faded. I'm going to use some purple from now on, okay? So I have q minus 8, right? So I'm going to do the opposite. The opposite of that is adding 8, right? I'm going to add 8, okay? And reminder that this is doing the opposite, and we're doing it to both sides, right? So I have a -8 plus 8. That's the opposite. And I'm going to add 8 over here. I'm going to plus 8 on this side because that's doing it to both sides. I got 2 rules here, right? 2 rules, all right? Do it to both sides. And so I can cancel my opposites, right? -8 plus 8 cancel. And I need to use -9 plus 8, right? -9 plus 8. You can use your calculators or a number line. You should get q is equal to -1. Okay, so right now I'm going to have you stop the video, right? You can let it run, but I want you to stop the video and try 2 problems for me, okay? So the first problem is on page, and we're going to check these up here on the board. The first problem, okay, is on page 438. I want you to try problem A. And then the second problem is on page 439, and I want you to try problem F. Okay, so go ahead and stop your video. I'm going to erase this and put those 2 on the board so we can check in just a second. Go ahead and try those 2. Okay, so I have my 2 problems, A and F up here. Okay, A and F up here. These are the 2 you should have tried on your own. All right, so let's go ahead and see if we can't solve these. Remember, solving means get the variables by themselves, okay? So we're going to have to do that to the y and to the r, right? Those are the 2 variables, which means we need to move the +6 and we need to move the -4, right? We need to get those away from our variable. So step 1 says do the opposite. So the opposite of +6, right? The opposite of +6 is -6, right? The opposite of +6 is -6. And step 2 says do that to both sides, right? Do it to both sides. So 6 minus 6, right? 6 minus 6 cancels. And now we just have a 9 minus 6 over here, which is y equals 9 minus 6 is 3. Okay, let's try this next one. Problem F here, right? Problem F says -4, right? -4. So rule number 1 says do the opposite. Well, the opposite of -4 is +4, right? +4. And if I'm going to do that to both sides, right? If I want to add 4 to both sides, I need to add it over here. Okay, so our opposites, right? -4 plus 4, -4 plus 4 are opposites, and opposites cancel, right? So I'm left with R equals -2 plus 4. You can use a calculator or a number line. -2 plus 4 is equal to R equals 2, right? R equals 2. Okay, so we're going to try a couple more here. We're going to do them a little bit differently, okay, or a little different style problem. So go ahead and join me. I'm going to a different page in our ebook right now. So that page is 448. So go ahead and join me on 448. We're going to do a couple of problems up here on the board. Okay, so let's check in, right? Because these should look differently than the ones we've just done. So the first question is, are these equations? So go ahead and look at these four problems. I have problems 1, 2, 4, and F here, sorry. And just think to yourself, are these equations? Well, the answer is yes. And the reason is because they still have equal signs, right? So as long as we have equal signs, that's what makes it an equation. And when we have an equation, we are going to solve, right? We're using that S word again, solve. And remember, solving means getting the variable by itself, right? Get the variable on one side of the equal sign with nothing else there. That's our goal. That's what solving means, okay? So we have the two rules, right? We have the two rules to do this. The first rule is do the opposite. The second is to do it to both sides. So we're still doing the same thing, even though these look different, okay? So I'm going to give you a chance. Look to yourself and see if you notice the real difference between these four problems and the first two. Hopefully you noticed the difference was that the first four problems we were adding or subtracting, but with these we are multiplying or dividing, right? So we're going to do something slightly different. We're still going to do the opposite, right? And we're still going to do it to both sides. We just have to be cautious about what we see. So look at problem 1 here, right? Let's find the variable. Remember, we need the variable to be by itself. And at the moment, it's not, right? This x has this 4 that's right out front, right? The 4 and the x are just kind of bunched together here, right? So what do we know about numbers and letters that are bunched together? What's happening between the 4 and the x? Well, the answer is they are multiplying, right? These two are timesing each other, okay? So we have to think, what is the opposite of multiplying? What's the opposite of timesing? The answer is division, right? It's dividing. So I'm going to write a division bar like a fraction bar, right? This is timesing 4. So the opposite of times 4 is divide by 4, which is what I'm doing here. Now, step 2 tells me, right, if I'm going to do something to one side, I must do it to both sides, right? So if I'm going to divide 4 by 4, I need to do that to the other side. That's the second rule of solving. So let's look. We have opposites here. We have times by 4, we have divide by 4, and those two should, right, they should cancel, right? 4 over 4 just gives us 1, and we don't really need to say 1 times x. We could say 1 times x, but we can just leave our answer as x. All right, so the one step, right, because these are one-step equations, the one step is to actually divide. What is 20 divided by 4? And some of us might be able to come up with that in our head. Some might need to use our calculators, but 20 divided by 4 is 5. Our answer is x equals 5. Okay, so let's try problem 2 down here. Let's try problem 2. What's happening between, this is a negative 8. What's happening between negative 8 and this y? They're just bunched together. I don't see anything that's happening between them, which means they must be multiplying, right? These two numbers are timesing each other, and we need to do the opposite, right? The opposite. So what's the opposite of multiplication? Well, it's division, right? Just like we just said, the opposite of multiplication is to divide. once again, I'm using this fraction bar as division, okay? Fraction bar as division. So if I divide on one side, I must follow step 2, which is divide on both sides, right? Divide on both sides. So opposites here, we have a -8 times and a -8 dividing. These two opposites over here, they cancel, right? We do the opposite, so they cancel with each other. Okay, so let's come to this side, and before we continue, let's decide if our answer is going to be a positive or a negative, right? So I have a positive 24 and a -8. So how many negative signs do we see? Well, we see 1. So is that odd or even? That's odd, right? And what does an odd amount of negatives mean for our answer? Odd amount makes our answer negative, right? So this should be y equals a negative 28 divided by 8, or 24 divided by 8 is a -3. And you can check that in your calculator. 24 divided by -8 should be a -3. Okay, so let's look at problem 4. I have a goofy looking fraction up there, right? I got a over -4, and it is equal to -9. Okay, so refresh, we just talked about this. What are fractions? Fractions are what type of math? They're division, right? They're dividing. So this fraction, a over -4, is dividing. Okay, so what's the opposite of dividing? It's timesing. So let's times this fraction. If I'm going to use this dot. Okay, I'm going to use that as a times symbol. If we're dividing by -4, I need to times by -4. I need to times, right? Because that's the opposite. And remember, if I'm going to do it to one side, if I'm going to times on one side, I must do it to both sides. I must do it to both sides. So I'm going to times this side by -4, right? So I'm doing the opposite on both sides. The opposites cancel, right? The times and divide by -4 cancels, right? That's the point of opposites. We're left with a equals, and let's talk about the negative real quick. First off, I have two negatives. I have a -9 and a -4. Two negatives is even, and an even amount will make our answer positive, right? So I'm going to say 9 times 4 is 36. It looks like A is equal to 36 in problem 4. Okay, so last question here, right? Last question for problem F. Okay, so it says m over 5 equals -7, right? M over 5 equals -7. Right? So the first question is, what's happening, right? What's going on between the m and the 5? So hopefully we know that that's division, right? This fraction bar is division, right? And we need to know what's going on because we need to do step 1, right? Step 1 is do the opposite. So if they're already dividing, what's the opposite of dividing? Multiply, right? We're going to times. So we're going to times, and we're going to times it to both sides. So if I'm dividing by 5, the opposite of that is times by 5, right? Times by 5. And if I'm going to times this by 5, I need to times this other side by 5, right? I need to times both of them by 5 because those are the rules. So the two opposites, right? The two opposites will cancel. 5 and divided by 5, those cancel, and I'm left with m. Right? M is equal to -7 times 5. -7 times 5 is a negative. There's one negative, -35. Right? So my answer for F is m equals -35. Okay, so I'm going to give you a couple more problems. I want you to check these right now, okay? And I'll put them on the board so you can check them as I check. All right, so let's see. I want to go to, this is on page 448. Okay, I want you to do problem B. All right, it's at the bottom of 448. And then go to 449, and I want you to do problem E. Okay, so I got B and E, please. B and E. Okay, let's look at these two problems, B and E here. Okay, so let's start by what's happening. What's going on between the variable? Excuse me, just popping in there. Between the variable and this -6, what's going on between the A and the -6? Hopefully, we all realize when we have a number, we have a letter that are bunched together like that. It is multiplication, right? This should be timesing. So we need to do the opposite of timesing. The opposite of timesing is dividing, right? This is division, right? And step 2, right? If we do something, we must do it to both sides, right? We must do it to both sides because that's what keeps it equal. So I have two negatives over here, the 2 -6, the opposites cancel, right? You can just cross them out if you like, right? This is A, and let's talk about our answer, whether it's positive or negative. First off, I have one negative sign here, one negative. One negative means our answer will be negative, right? Because it's odd. So what's 36 divided by 6? You should have gotten a -6. A equals -6 in this problem. All right, let's try problem E. Right, so there's a difference, right? Something's happening between the Y and the -3. There is something going on, okay? However, it's not what was going on up here. This is a fraction bar, right? The fraction bar is division, right? So they're dividing. So the opposite of dividing, right? The opposite of dividing is multiplication. We will times. We're going to times by -3. And we do one thing on one side, we must do it to both sides. That's rule number 2. That's all times -3 on both sides of this equation. Now, these opposites, you guessed it, they cancel. And so we're left with Y. All right, and then let's look at our answer. If it's going to be positive or negative. I see 2 negative signs this time, right? 2 negatives is an even amount, and even means our answer will be positive. So 8 times 3 gives me a positive 24. It looks like Y is equal to 24 in problem E. Okay, folks, that's the end of this video. Reference it if you need assistance. Your substitute should give you a list of problems once this video is finished. Okay, so if you have questions, let me know, and I will be around when I can to answer them via email or classroom. Take care.